everyone. Today we are going to study Newton's laws. So we studied how to calculate position of particles as a function of time once we know accelerations. We will study how to find accelerations. Newton's law plays a crucial role to find accelerations. So in the second chapters, we study the mechanics, especially in the case of the point mass. First topic is Newton's law. Second topic is the work, kinetic energy, potential energies. And the third topic is the momentums. So today we are going to study the Newton's laws. First topic is the Newton's laws, and the second topic is force. And the third topic is application of Newton's laws. So Newton's law is a fundamental statement for mechanics. Newton's law consists of three laws. So today we'll study these three laws, three Newton's laws. So Newton's first law said a body acted on by no net force moves with constant velocities which may be zero and zero accelerations. So net force is zero means two forces acting on the object, force A and force B. And force A and force B is directed in the opposite direction, same magnitude. So in this case, net force is zero. So we could apply the Newton's first law because the net force is zero. In these situations, a body moves with a constant velocity. Maybe sometimes it's going to be the zero velocities and zero acceleration. Body is in equilibrium. The frame of reference in which the Newton's first law is valid, because this is inertial frame of reference. So Newton's first law actually claims that the existence of an inertial frame of reference, at least one inertial frame of reference exists in the universe. Okay? The Newton's second law we are going to study. Net force acting on a body causes the body to accelerate in the same directions as the net force. The magnitude of the acceleration is directly proportional to the magnitude of the net force acting on it. So we consider the object. Mass of the object is lowercase of the m. And the force is acting on this object. Magnitude of the force is F. In these situations, object is accelerated with the magnitude of the acceleration of A. Then F ma is related the equation of E equals F equal ma. This is Newton's second law. Unit of the force. 1 Newton is the amount of the net force that gives the acceleration of 1 meter per square second to a body with mass of 1 kilogram. The unit of mass is kilogram, and the unit of the acceleration is a meter per square second. From the Newton's second law, F equal ma, the unit of the force is 1 Newton is expressed. 1 Newton is equal to 1 kilogram, meter per square second. Sometimes the several forces acting on the object. Then we have to sum up the forces to find the net force acting on the object. Then the net force is given by the superposition of force. This is the vector sum. So in this situation, F sub 1, force of the F sub 1 and the force of the F sub 2 is acting. The net force is calculated by the vector sum. If we apply the component forms, x component of the force is given by the sum of the x component of each force. And F sub y is also given by the sum of the y component of each force. So vector forms the equation of motion. If a net external force acts on a body, the body accelerates. Direction of the acceleration is the same as the direction of the net force. Mass of the body times the acceleration of the body equal to the net force vector. Ma equal F. This means x component, y component, and the z component. We can separately write down the equation of motion. Finally, the Newton's third law. If a body A exerts a force on the body B, so in this situation, we consider this is the body A, this is the body B. Then body A exerts a force on the body B. This is action. So this is, we call this force is action. Then the body B exerts a force on the body A. This is reaction. These two forces have the same magnitude but are opposite in directions. The two forces in the action-reaction pair never act on the same bodies. So actions act on the body B and the reaction act on the body A. Okay, we have studied Newton's three laws in these sections. This is the end of this session.